Hello, my AMA class. I am at a meeting, so I don't get to see you, and I know that some of you wanted to see your finals and what you got wrong and stuff, and I originally had scheduled that we were going to go over your finals today, but it turns out we will not be able to do that until Thursday. So Thursday, be prepared then to be handed back your final and a copy of everything you submitted and a copy of what questions you got right and what you got wrong. We'll do that all on Thursday of this week. So what are you going to do while I am not here? You are going to work on worksheet 1 for 6.1. We're going to be starting a whole new unit. And worksheet 1 is very similar to what you see on this piece of paper over here to my right. You are going to be plugging certain things into your graphing calculators and figuring out how to graph them. I'm not going to do all of these for you. You're going to end up doing them during class, but I'm going to show you a couple of things that you should know. So I'm going to start with number 2. Number 2 says y equals x squared. You can see that right there. So let's say I did not know what the graph looked like. You should know what it looks like, but let's say you did not know what it looks like. First thing you need to make sure is that you're back into function mode onto your calculators. We're no longer in parametric or polar. We're back to functions. Radians or degrees, it's not going to matter this time, so I'm going to put radians, but it really doesn't matter because there's no angle here. And then under y equals, I'm going to put in x to the second power and press enter, and then I'm going to zoom it, and I'm going to do zoom standard just so I can see what the graph is. Remember, the standard window is usually a -10 by +10 x-axis and a +10 and a -10 y-axis. So here's my graph. Y equals x squared is a parabola, but you knew that already. What you're going to do is you're going to put that here on your graph. And one of the directions says, make a note of the point when x is equal to -1 and x is equal to 1 on your paper. So here's what I want you to do on all these graphs. What is, when x is 1, what's y going to be? So if you need to, you can go over here and plug in 1, square it, and figure out what y is going to be. Well, I'm hoping you know that it's 1, 1. So I'm just going to put a little dot there, just so that I know where this graph is at when x is 1. Well, what about when it's -1? When I plug in -1, and remember it's in x squared, the whole x is being squared, so it's technically -1. The entire thing is being squared. It's a -1 times a -1. And that's going to mean that -1 is going to be a +1. -1 times -1 is a +1. So I put these two little extra dots because I'm making a note of the points when x is equal to -1 and x equals 1 on all of these graphs, just because I want you to know where those pieces are. Even though these are sketches, I still should know where those points are. And I can figure them out by plugging in 1 into those functions. Okay? And then it's going to ask me, what's the domain? The domain is what are our x values? What are our x values? What can I plug in for x? And since this goes up and to the left forever, these are my x values. Domain is my x values. I have an x here. 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 I have all these x's. I'm using all real numbers for my domain. There is a part of this graph that is on, or that is touched, that uses this. Is there a part of this graph when x is 5? Is there a part of the graph when x is 10? That's what I'm saying when I say the domain is all reals. What about the range? What range stands for the y values. If you don't remember that, you can write down y values right here. Domain are your x values. And what y values? So there is a y value here where it's going to touch this part of the graph. And since this goes up, I use all these y values above this line. But are there any y values down here below this graph? You should be thinking no. So how do I write that? I have y values that are equal to this line and above. How would I write that? Y is greater than or equal to 0. Okay? So that's the basics of this, of what you're going to be doing. You're going to be graphing these, making specific note of those 2 points. You'll be writing the domain and the range, and then we need to write and find its inverse. What's its inverse mean? That means what happens when you switch x and y. So, for example, if this is the graph y equals x squared, then the graph of its inverse is the graph of x equals y squared. The inverse is when you switch the x and the y. So since I'm switching the x and the y, what ends up happening is the graph to the original equation will flip or rotate about the line y equals x. Here's what I mean. If I have this original graph, that's right here, and I were to draw a line, this is not part of the graph, but I'm just showing you for measure. This dotted line that I have is y equals x. If I had a solid line there, that's the graph of y equals x. If I were to use that and fold my piece of paper along that line, what would the new graph look like? Okay? And this is what it would look like, okay? Instead of it opening up like this and it folded along that line, my graph would look like this. I did something a little different there, and I realized, so the inverse is where it folds over, and normally it would look sideways, and there would be a completely horizontal parabola. I should make a small change in these directions. It says, make a graph of given the equation and its inverse function. Let me be specific on this. The inverse should be a function. So right now on your sheets, make sure that you know that you are supposed to graph the inverse functions. It doesn't say inverse functions. You need to write that in there. And this is important because in order for something to be a function, it has to be one-to-one. It means that every x has to have only one y. You have to pass the vertical line test if you remember that from Algebra 2. So, if I'm looking at this inverse and a vertical line would hit it in more than one spot, it wouldn't be a function anymore. So what that means is we are limited on any inverse that is like this. We cannot graph an inverse function. If I were to graph this, it would not work out. I couldn't graph the inverse because it wouldn't, or the inverse function because it wouldn't be a function. So I have to do half of it. I can only do the inverse if I do half of it, either the positive value or the negative value. So what I want you to do is if you ever have an inverse that is not a function, you're going to graph half of it, the positive values, with a solid line and the negative values with a dotted line, like so. At x equals 1, I have this point. Y would have to equal 1. Or, at x equals 1, it could be down here, -1. I'm just making a couple of notes of it. There is no value when x equals -1. There's no way for me to square y and end up with a -1 for x. So with that being said, what's my domain now? My domain, x's have to be greater than or equal to 0. My y's, my range, the y's, remember I'm only talking about the solid line here. I'm not really talking about the entire inverse. I'm talking about the inverse function, which means only half of this. I only want you to write the domain and range for the solid or the positive portion. And so the range here would be y has to be greater than or equal to 0. We're stuck with that limited domain and range because that's what works here. Okay? So that was one example of what I want you to do on this worksheet. You have to figure out to graph like y equals x to the third, 1 over x squared, y equals absolute value of x. What would that look like? Square root of x, e to the x, natural log of x, and so on. So let me do number 6 with you. Y equals absolute value of x. If I go here, if I want to do absolute value under math, under numbers is absolute value. And you can see that I have absolute value of x there. So now I have the function. That's what my function looks like. I'm going to draw arrows because it goes up and forever to the right and to the left. When x is 1, what's y going to be? When x is negative 1, what is y going to be? My domain, I go for all the x's to the left, all the x's to the right. I have all real numbers. My range, y is greater than or equal to 0. Very similar to the one we just did. If I were to graph the inverse is technically x equals the absolute value of y. I'm switching the x and the y. That's what the inverse means. I'm doing that again for you. It means that I'm flipping this graph along the line, the diagonal, that would go down quadrants 1 and quadrants 3. If I think about that, where would that end up if I folded it? It would look just like this. Why am I doing the dotted line? Because it is not a function. It's not a function. If it would not pass the vertical line test if I were to draw it as a solid line. On the other ones that I've shown you, that they're up here, 1 through 5, most of them the inverses will be functions. This inverse particularly is not, so I have to have that dotted line. And now what's the domain? I have x values that are greater than or equal to 0. The y values are also greater than or equal to 0. And remember, this domain and range is only for the solid line. It is not for anything else. Let's see. Is there anything else that you need to know when I look at this worksheet? You should know where E is on your calculator. E is a number that basically is about 2.718. E on this calculator is right above the divided by key. There's the E right there. On the Casios, be careful. E automatically assumes you're going to have an exponent. You don't need to put E to the, because it will already be there for anybody who has the Casio calculator. All right, so with that being said, what my plan for you to do today is you are going to finish all 20 of these graphs. You will plug them into your calculators. You will find the domain and range for all of them. And then guess what? You get to start memorizing them, because I will be fully expecting you to take a quiz on all of these by next week. You should know all these by next week, memorized. Use flashcards. Cut them up if you need to. We will do what it takes.